Everyone, Victor here again, and in today's lesson, we'll be learning about one of the Kubernetes and OpenShift components called service. Before we learn about service, I will create a pod and increase the quantity of the pod so that you can have clarity on what I'm about to explain. So to create a pod, of course, I'm going to do create deployment nginx app image equals nginx. So you can see that the deployment has been created, and if I do oc get deployment, we already have the deployment created, but the pod is not running yet. So if I do oc get pods, so the container is still creating. So that's the status we have here. So I need to keep checking. So if I wish, I can just add the watch option. So we can see now that the container is running. So if I cancel this and do get pods again, so we have the container running. So what I'm going to do is to create replicas of this container. So I want to increase the quantity of the pod. And of course, currently we just have one pod running from this deployment. And to increase the quantity of the pod, I can easily use the command oc scale deployment nginx app replicas. So I'm going to increase this to 4. So you can see now that this deployment has been scaled. Of course, we're scaling up, and if I do oc get pods again, you can see that they are being created. You can see here the status is saying that container creating. If I do oc get pods again, you can see that all the 4 pods are running. They are the same copies, and they are just inside of one deployment, and these pods will be distributed across different nodes. And in our case, the CRC node, since we are running a single node cluster. And if you do oc get options or wide, you will see the different IPs of the pod. You can also see that they are running on just this single node, which is this CRC node. At it being, we have the production architecture like this. You will see the nodes, like for example, worker node 1, here, worker node 2, worker node 3. You will see that the pods will be distributed across the number of nodes, the number of worker nodes you have in your cluster. But since we are just using a single node cluster, of course, they will be running on the same node, since the node is working both as master and worker node. If you log in into any of these containers, you will be able to successfully verify that nginx is correctly deployed, just like we did in our previous lesson. So now what I'm going to do is to scale down this pod. So what I'm going to do is to just scale it down to 2 pods. So from replicas of 4, I'm going to say 2. And now you can see that it's been scaled. And if I say oc get pods again, you can see that 2 pods out of 4 pods are being terminated rather, and the status is terminating. So if I run this command again, these pods are still being terminated. They're not done yet. And if I run this command again, let's see. So you can see now that we have just 2 pods running, and this has been scaled down to just 2 pods. This is one of the benefits of using deployment to create a pod. OpenShift will automatically do the scaling and automatically identify which node to add the replicas of the pod to and which node to remove the replicas of the pod from. Also, these internal IPs are automatically given to these pods by OpenShift. Having understood how to use adhoc to increase and decrease the quantity of a pod, now let's understand what service is. In our previous lesson, we learned how to use adhoc to create pod, and we also deployed a basic Nginx application. However, we could only connect to this containerized application, or rather to this pod, by having to log into the worker node where the pod resides, and in our case, the CRC node, before we were able to access the application. And at the end of the lesson, I mentioned that it doesn't make any sense to always have to log into the node before an application can be accessed. It is impractical, hence the need to create a service. You see, pods in nature, they are ephemeral, meaning that pods can die easily. And when a pod dies, of course, it dies with its internal IP address. And when the pod is being rescheduled and being recreated automatically, the pod loses its static IP because the pod IPs are always dynamically and randomly generated by OpenShift. Hence, other components or applications that are meant to talk to the pod will not be able to talk to the pod because another IP may have been randomly assigned to the pod. So to avoid this problem, Kubernetes and OpenShift uses a common or a component rather called service. The static IP address or addresses are assigned to a service instead of a pod, and the service sends the request to the pod. So a service can also act as a load balancer by load balancing requests and sending them to the appropriate or less busy pod depending on the request. Service gives you access into a pod via an IP address and port. Service is not ephemeral in nature, that is, a service doesn't die, or as some gangsters would say, a service doesn't go down easily, unlike pod. So there are two types of services, and they are the internal service and the external service. The internal service is used for internal communication within the cluster and doesn't expose ports or application to the external or outside world. It is good to use this type of service if you don't want your applications, especially databases, to be exposed to the outside world. And the internal service is called the cluster IP. The cluster IP will be attached to a deployment at the point of creation, and this IP will automatically be generated by OpenShift. So let's say you created a deployment which has 3 replicas of a pod. Instead of having to query just one single pod, the cluster IP can be created. Hence, you can direct your request or query to the cluster IP, and the cluster IP will forward the request to any of the pods and also do the load balancing among the pods. It can forward the request to the less busy pod, and this is one of the automated and load balancing features of Kubernetes and OpenShift service. Now let's see this in practical. Currently, we have 2 pods running on the system, and we have one deployment. So you can see the IPs of the pod. And for us to be able to test our Nginx deployment, just like we did, we need to log into the CRC node. And to do that, I need to get the CRC IP. So with the CRC IP, I can SSH into the CRC node. So I'm just going to copy the command from the website and paste it here. Like I said, I'll be dropping the link to the documentation in the description box below so that you can also easily navigate on the website and click on whatsoever you want to click on instead of typing. So now we are already logged into this CRC node. So if I do call to do my test, like I said, this pod, they are the same copy. So if I do call on this internal IP of the pod, you can see that I am getting a result. I'm getting the welcome result. If I also try it on this IP as well, let's try it on this IP as well. So you can see that we are also getting a result. I'm going to log out of this node. And now if I do OC get service, you can see that we don't have any service on this cluster currently. So to create an internal service, we're going to use the command OC expose. So we're exposing the deployment. So I'm going to say OC expose deployment nginx app, and I'm going to say port equals 8080. So I'm exposing this deployment to port 8080, and the target port is going to be port 80, and that is because by default nginx uses port 80. So the target port is port 80. So we're going to be exposing the port 80 on nginx to port 8080. And if I say enter, you can see that it's saying that this deployment has been exposed, meaning that the service has been created. So if I do OC get service, you can now see that we have a service, and the service type, like I said, is the cluster IP. And you can see the IP here, and you can also see the port here. So because this is an internal service, if I try to do call on this service with the IP, with the port number, say port 8080, you can see that I cannot get a connection, and that's because this service is internal and it is not external. Even if I do CRC IP and I do call to the pod where the to the node rather where the pod resides, and I do 8080, you can see here that we have failed to connect to this, and that is because this is an internal IP and it only allows communication within the cluster. So of course, again, for us to be able to do our test, we need to log in into the CRC node, and to do that, I'll just use this command, and I can now do call on this internal IP, on this cluster IP rather. So I'm just going to say call here, then I'm going to say 8080. So you can see now that I have an output. So let's log out of this CRC node. And if I also want to get wider information about my service, I can do OC describe service nginx app. So this will give me more information about the service. You can see the namespace, which is app project. You can see the labels. So in the next chapter, I would explain what labels, selectors are. So you can see the type of the service, which is the cluster IP, the target port, the event, and the IP here. So this is how you're going to create an internal service in OpenShift. So now let's talk about the external service. The external service is used for external communication, and it exposes pods and applications to the external or outside world. Of course, your web applications need to be exposed to the outside world so it can be accessible by the users. So you can create an external service for this use case. And there are two types of external services. We have the option to create the node port And we also have the option to create the load balancer. So the node port external service opens an application to the outside world through the node the pod resides in, and that is why it is called node port. So when a deployment is being exposed through a node, one would have to access the application using the node IP and a port. So let's see this in practical. What I'm going to do is to delete the service we just created. So I'm going to say also delete service nginx app, nginx, nginx app. So it's taking its time. So if I say OC get service, so you can see that we don't have any service here anymore. So I'm going to create the external service, the node port external service. And to do that, I'm going to say OC expose deployment nginx app and the type of service, which is node port, and this is going to be port 80. So we are getting an error here, which is saying unsupported value. Oops, okay, this is supposed to be node port. This is supposed to be in uppercase. So you can now see that this service has been created. So if I do OC get service, you can see the type of service, which is node port. So this is the node port external service. And like I said, you can only access the pod through the node where the pod resides, and the pod resides in the CRC node. So if I say CRC IP, so I can see the IP here, so I can now say I can say call rather on this guy, and I can use the random port which the service has given us. So normally you can always specify a port, but just for this use case, I'm going to be using the random port that has automatically been given to us. In the next lesson or in other lessons, we're going to look at how to specify a port. And if I say enter here, you can now see that we are getting the output that we want to get, which is welcome to Nginx. I can also do this on the web browser. So on the web browser, I can copy and paste. Let's see, did I copy it? So I can copy and paste the CRC. Oh, I didn't copy, so let me just type the IP address, which is 192.168. Let me check again. 130.11, and the port is 30300. So we're waiting for the output. And now we have the output we want to see, which is welcome to Nginx. So going forward, let's talk about the load balancer external service. The load balancer external service is mostly used on cloud, and the cloud service providers are the ones who provide this load balancer IP. Unlike the node port external service where requests are made through the node where the pod resides, in this case, the request will be made to the load balancer IP instead, and the load balancer balances the load among the nodes and sends requests to the appropriate pod accordingly. Now let's create the load balancer external IP. First, I'm going to delete the service, the node port external service that we created. So I'm going to say also delete service nginx app Oops. My cluster is beginning to become unstable. So I'm going to try this again. And now you can see that the Nginx app service has been deleted. So to create the load balancer external service, I'm going to use the same command, which is oc expose, but this time around, I'm going to call this type is going to be load balancer. So you can see that the service has been created. So if I say oc get service, you can see the service type to be load balancer, and you can also see the IP, but you can see that there is an external IP that is pending, and this is pending because we are not making use of the cloud service provider. Like I said, this deployment is happening on premise and it is OpenShift local node. If we were using a cloud service provider, the IP address would have shown here where we have pending. The cloud service provider would have given us the IP address. When you connect to that same IP address that you have, you can always connect to any of the pods. So this is how to create services in OpenShift cluster. This is one of the basic networking technology in OpenShift. And before I round off with this course, or with this lesson rather, I'd like to quickly do something. So I'm going to just delete all the resources I have. So to make it easy for me, I'll just say oc delete all all. So this will delete all the resources I have in this namespace. Now that I have all the resources deleted, I'm going to um, I'm going to create another pod using the OCNU app. Here. So image is going to be Nginx name equals to Nginx app. All right, so this is going to create another pod. So it's taking its time. All right, we have it being created. So if I say oc get, so like I mentioned in the previous lesson, this is going to automatically create a deployment for us. So if I say oc get deployment, I have the deployment. If I say oc get pods, so I have the pod and it's being, you can see status here, which is saying container creating. But while this is creating, this is what I want to drive out here. I told you that one of the best ways to create a pod or to deploy an application in OpenShift is by using the OCNU app command, because this will automatically also create a service for you. So if I say oc get service, so I'm sorry guys, I need to leave very fast. So oc get service, you can see that we have the IP being created for us. We have the service rather being created, and you can set the type of service, which is the cluster IP. So this is just what I want to bring out here. And I want to say thank you for watching. I want you to please subscribe, like, share, comment, and yeah, share. Thank you once more. I'm going to see you in the next lesson. Bye for now.